Assalamu alaikum. How are you students? Today we will cover another unit of O-level physics 5054, unit number 27, the nuclear atom, that is the concept of isotopes. Today we will cover the last two learning outcome of this unit, and in this way we are able to complete this unit. So let's proceed towards the definition of isotopes. Isotopes are basically atoms of an element that are having same number of protons but different number of neutrons. In other words, we might say that they have same atomic number but different atomic mass number. But it is always recommended that whenever this definition is being asked in the examination, always you are recommended to write the same number of protons but different number of neutrons. So a very famous example of isotope is the isotopes of hydrogen. Before we will consider that example, we will definitely consider the key which is being used behind the diagrams on the softboard. That is, black color represents number of electrons, red color represents number of protons, and blue color represents number of neutrons. So now you can see on this whiteboard that I have drawn three diagrams. In diagram number 1, there is only one proton. Diagram number 2, there is also one proton, and in diagram number 3, there is also one proton. So it's mean that all these three atoms have same number of protons. Excuse me. And now if we will look the number of neutrons, here there are two number of neutrons, there is only one number of neutron, and there is no neutron over here. So this is called as protium, this is called as deuterium, and this is called as tritium. These are the isotopes of hydrogen, and by using nuclide notation, we can represent these like this: hydrogen, hydrogen, hydrogen. Since the nuclide notation was like that, Z and A, so we will write over here, since number of protons are 1, so we will write here 1, 1 and 1. Okay, now the atomic mass number, definitely atomic mass number will be equals to number of protons plus number of neutrons. Since there is no neutron over here, so definitely 1 plus 0 is equals to 1. And there is one neutron over here along with one proton, so 1 plus 1 is equals to 2. There are two neutron and one proton, so 2 plus 1 is equals to 3. So in this way, by using nuclide notation, we can represent different isotopes of hydrogen: 1H1, 1H2, 1H3. And definitely if we want to calculate number of neutrons, obviously it will be equals to 1 minus 1 is equals to 0. In this example, number of neutrons minus 1 is equals to 1. And in third example, number of neutrons is equals to 3 minus 1 is equals to 2. So in this way we can calculate number of neutrons given in the isotopes. So again I am going to revise this definition. Isotopes are the atoms of an element having same number of protons but different number of neutrons. And the very famous example of the isotopes of hydrogen, 1H1, 1H2, 1H3. In 1H1 there are no neutrons, in 1H2 there is one neutron, and in 1H3 there are two neutrons. Now we will consider another example of isotope. Okay, now we will consider another example of isotope, and that is isotope of carbon. Now you can see that how many electrons are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And how many number of protons are there? Obviously number of electrons are equal to number of protons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's mean that number of protons are same. So for carbon we will write here number of protons. How many number of protons were there? 6 number of protons were there. So I will write 6 over here for nuclide notation. And now we will count the number of neutrons. 1, 2, 3, 4, 5, 6. So 6 neutrons are there, and the value of A will be equal to 6 plus 6. Atomic mass number will be always calculated by total number of protons and total number of neutrons. So 6 plus 6 is equals to 12. So number of neutrons is equals to 12 minus 6 is equals to 6. Now consider example number 2. 1, 2, 3, 4, 5, 6, 7. So 7 plus 6 is equals to 13. So I will write 13 over here, and again number of neutrons is equals to 13 minus 6 is equals to 7. In third example, how many neutrons are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 6 is equals to 14. And we will write number of neutrons is equals to 14 minus 6 is equals to 8. So these are different isotopes of carbon. So C612, 6C13, 6C12, 6C13 and 6C14. So these are the isotopes of carbon. And what are the isotopes? Atoms of an element having same number of protons but different number of neutrons. Now we will discuss few examples from past papers regarding this topic.